Okay. I hope that the sound on this is okay for you guys. I can't plug in the tablet and my headset, and so while I can kind of hear myself on the replay in my living room here, I'm hoping that it gets loud enough that you guys can hear what I'm saying when you're watching these at home. We're going to talk about drawing just a single card out of a deck of cards, and not everybody plays cards or is familiar with the way a deck is set up. So we'll make sure that we're on the same page there. Okay, a standard deck of cards is broken down into 4 suits. We have hearts and diamonds, spades and clubs. These suits are 2 different colors. The hearts and the diamonds, those are the red cards, and the spades and the clubs, those are the black. Okay. Now spades, sometimes I try to draw them on the board, it'll be awful here. But spade looks, that looks like a mushroom, but more like that. And when we're talking about the clubs, it's kind of like a 3-leaf clover. But again, they're both black. A heart and a diamond, of course, should be self-explanatory. And if I draw them on the board, if I get lazy and don't want to write the words, it would look something kind of like that. There are 13 cards in each suit. Instead of a 1, there's an ace, and then it goes 2, 3, 4, 5, 6 through 10. After 10 is a jack and a queen and a king. There's 52 total cards in the deck. We are not counting the jokers. I almost no problems ever will ask you to include a joker. Okay. All right, so let's say that I'm going to draw, and it says a card. I'm drawing a single card out of the deck. And I want to know the probability that that card is going to be a heart. When we're drawing a single card out of a deck, the denominator in all of these problems is going to be 52. There are 52 total cards in the stack, total cards in the deck, and so if I count them up, and we look, if there are 4 suits, and there's 52 total cards and 13 cards per suit, over there from the list, 13 of them are hearts, so we would have a 13 out of 52 chance of drawing a heart. That reduces to lowest terms as 1/4. Okay. If I want to find the probability that the card that I draw is an ace, then out of the 52 cards in the deck, and we're assuming each time after we've drawn this card, we put it back in and shuffle again. Okay, when we start talking about compound events, that's another section down the road. So out of 52 cards, there are 4 aces in the deck, 1 each of hearts, diamonds, spades, and clubs. And so when we reduce to lowest terms, that's 1 out of 13. If I want to know the probability that I get a red card, say, well, there are all of the hearts and all of the diamonds, and so altogether 26 of those cards out of 52 are going to be red cards. So half the time I should get a red one, and half the time I should get a black one. At your house, go ahead and think through the probability that you would draw a spade if you drew a card out of the deck, the probability that you'd get a face card. When I talk about face cards, I'm specifically talking about a jack, queen, and king. Okay, and not including the ace. Some people try to include the aces there. If I want to find the probability that you have a number card, so not the ace, not the jack, not the queen, not the king, but less than 5. Pause the video for a moment, and again, all of these on the bottom will be 52 to start with. Okay, pause and count up how many cards you believe fall into each of those categories, and then reduce to lowest terms if you're not there already. And when you turn it back on, the answers will be there, so don't turn it on until you're ready to see. Probability of drawing a spade is the same as probability of drawing a heart, or we could have said diamonds, or we could have said clubs, because there's 13 of each of those. And 13 out of 52 reduces to be 1/4. If we're talking about jacks, there's 4 of those, and 4 queens and 4 kings for a total of 12 face cards out of 52, and so we reduce. When we set a card less than 5, and a number card, remember I was kind of sloppy the way I wrote it, so not an ace, we are talking about 4 or a 3 or a 2 here. Because ace isn't a number card, and it says less than 5, so that doesn't include 5. So again, there's 4 of these, 4 of these, and 4 of these, also 12 out of 52, reducing to 3/13. Alright. If we want to talk about the complement, I wanted to bring that back in here, and I haven't found my best place to do that, so we'll sneak him in here, and then we'll do one in my next video as well. One thing to keep in mind, that if I take the probability of an event happening plus the probability that that event will not happen, okay, altogether that should always add up to 1. Now, in our deck of cards situation, it's not usually any easier to find one over the other, but there are some situations where it's easier to find the probability of the complement, and if I know this value, I can subtract it from 1 to find the probability of my event. So maybe I want to know the probability that I draw something that is not an ace. Okay. Of course, we could count up all of the cards out of 52 that are not an ace, and write down how many those are and reduce to lowest terms. Or we could say up here the probability of drawing an ace is 1 out of 13. And if the probability of drawing an ace is 1 out of 13, if I take 1 minus that probability, that leaves me with the rest, the probability of not drawing A. So again, if we take these 4 cards out of the deck, the 4 aces, there are 48 cards left in the deck. If I reduce 48 out of 52, I get 12/13. Or if I already knew the probability of drawing an ace, I can subtract it from 1 and say, well, here's the probability of not getting one. Okay, this is a good way to get the probability of a complement. Still haven't gotten to empirical probability yet. That'll be in the next video. Okay, one more time. Hang in there with me. We'll get through 4.1.